Hello everyone, this is lecture series 11 Network Security Handshake Protocol dealing with phase 2, phase 3 and phase 4. In previous video we have seen about the phase 1 of Handshake Protocol. Come, let's go into the video. Please do like, share, subscribe and comment. So what is phase 2? Phase 2 is nothing but it is server authentication and key exchange. So in phase 2, authentication of the server takes place, and also to ensure the authentication, there is an exchange of key that is taking place through the server. So here what happens is the server will begin this phase by sending some certificate which is completely authenticated. So that message will have some functions like it is completely authenticated, integrity is maintained. So next what happens is the server key exchange message will be sent. So it is not required for every instance of time, but it requires this message to be sent for assuring that the server authentication is done. So now when server key exchange message has to be sent means there should be two requirements, two instance. What that two instance is, the server has to send a certificate with fixed Diffie-Hellman parameter, or RSA key exchange has to be used. So for this server key exchange, we need some of the following methods like anonymous Diffie-Hellman, ephemeral Diffie-Hellman, RSA key exchange and Fortessa. So anonymous Diffie-Hellman is nothing but this message will contain some global Diffie-Hellman values, that is it might be a prime number, so which authenticates the server. Ephemeral Diffie-Hellman, so what happens here is this message may include some Diffie-Hellman parameters wherein it should be provided for Diffie-Hellman signature value also. And RSA key exchange is nothing but when a client cannot send a secret key which is completely encrypted with server's public key. So what happens is the server can create a temporary RSA key exchange which can be shared between the clients for authentication. And Fortessa, it might be used, it might not be used. Next is, if you are using hash algorithm for authentication purpose, then this is how your algorithm will be. You are using hash algorithm wherein client is sending message, client hello random. So from some random client is sending hello message to some random server. So server hello message is also sent by the server. Then the server is checking for the parameters, whether the RSA parameters or Diffie-Hellman parameters, signature parameters are available. And suppose after that, if you are using hash algorithm and the exchange of client and the server authentication is done, then next you have to move for some public key exchange, wherein some algorithms like RSA signature only, DSS signature only, RSS for fixed Diffie-Hellman, DSS for fixed Diffie-Hellman, DSS for ephemeral Diffie-Hellman. So these are some of the certificate types that can be used, wherein this certificate request message is having two types, that is certificate type and certificate authorities. Certificate types is nothing but these are the types that is involved to certify the authentication process. Certificate authorities is nothing but when these certificates become authorized. How it become authorized is only when certificate authorities sign the particular certificate, then only the authentication is carried out. So finally what happens using hash algorithm, using different types of certificates, seeing whether it is authenticated, finally in phase 2 server done message will be sent. Coming into phase 3, so phase 3 what happens is, here the client authentication and key exchange take place. That is, when the server done message is received, the client has to verify the server, like provided whether a valid certificate is provided, whether the server hello parameters is authenticated, all those will be checked from the client side. So now what happens is, if there is no suitable certificate available, the client will be sending no certificate alert. If suppose it has verified all the certificate, the client will send certificate verify message. So when client is sending client key exchange message, then this must be exactly sent to exchange a key which is initiated by the client side, which may have the parameters like RSA, ephemeral, Diffie-Hellman, fixed Diffie-Hellman, Fortasa. So these are the some parameters that is required for the key exchange. And suppose if you are using some signature value, signature certificate, so this is the hash algorithm that will be used, which will be in the cryptographic form. Certificate verify dot signature dot MD-5 hash. So hash value you are using, wherein you are verifying whether the certificate signature is authenticated using message digestify, and this message master secret code is shared between the client and the server with padded values. And then again, it is either it uses MD5 algorithm or SHA hash algorithm. So MD5 means this is the procedure, SHA means the same procedure wherein your hash algorithm will be replaced by SHA hash algorithm. So within that you will have handshake messages with authenticates client and the server, and also master secret code is shared, and finally it verifies the certificate. Finally going into phase 4, which is called as finish phase. So here the client will send the finish message when all the secret keys, key exchange, algorithm, everything is completely verified. Then it sends finish message. Or if the client doesn't send finish message, then it is understood that there is no proper key generated between the client and the server, or there are some errors that is happening while using algorithms, hash algorithm, to verify the authentication process. So once the finish message is sent by the client, then successfully all authentication process is done. Hope you have understood phase 2, phase 3, and phase 4 of Handshake protocol. Please be stay tuned for more information. Thank you.